All right, guys, Stat 1800. More on two-sample hypothesis testing. Go start out with a question. So, is there a difference in the proportion of men and women who buy clothing from their mobile devices? I can't even look at this without laughing. Because my wife, she would buy from a mobile, immobile, I mean, it doesn't matter. She's going to buy clothing. Test at the 0.01 level of significance. Now, so tempting to kind of use what we've done before and say, well, H0 mu1 equal mu2, but the problem is we don't have a mean problem. We have a proportion problem. We have a percentage problem. And as you should know by now, even back in the one sample problems, those things are, they're handled differently, okay? So first thing I'd want to do is set up my null hypothesis. So I would say that the proportion for men is the proportion for females, well, males and females, and the alternative would be the proportion for males is not equal to the proportion for females. Tested 0.05, 0.01. Going to mix it up a little bit just so you guys see a different type of problem. And we go for it. Now, one thing I can tell you is just like the one sample problems, these problems aren't worked with a t-distribution, they're worked with a z-distribution. And this is just using the normal on your calculator. Now, I'll tell you guys, the notation on these types of problems is pretty insane. So just go ahead and kind of get ready for that. So, guys, let's say that we go out and we collect our data. And for the males, we go out and collect 500 males, and we ask them, hey, do you use your mobile device to order clothing? And let's say that, no, I don't know. I'm going to try to come up with something kind of cool here. 195 do, and then for females, let's say that we also collect 500, sample of 500, and we find that 305 actually say they. Now, we look at that, and there's clearly a difference of the 500, that there's a higher percentage of females who use their mobile device. But again, we got to let the process play out and go from there. All right, guys, a lot of information we've got to get before we start one of these things out. Whole kind of a plethora of things. So first thing we got to do is we got to get P1, which is the proportion, in this case, of males, which is going to be X1 over N1. So the proportion of males is going to be 195 over 500, which looks like to me that's going to be, what, 0.39? Yeah. And we need P2. And this is going to be X2 over N2. So X2 in this problem is 305 out of 500. And it looks like to me that's going to be 0.61. Just let me check that because I don't want to do something goofy and wacky. Now, going to need some more stuff. What is pi 1? Well, that's the proportion of all males who use their mobile device to purchase clothing. That's unknown. And pi 2 is all females who use their mobile device to buy clothing. So again, P1 is the proportion. I guess let's be of all males, and P2 is the proportion. Guys, these are unknown. All right. Now, next thing we're going to need is we're going to need this. Well, it's a pooled variance. I don't really even know what it's called. It's just a pooled estimate. This is almost like typically a line over. I'm not even sure it's a line. If I remember correctly, I think it's just dot, dot, dot. Anyway, this is the pooled estimate of the population proportion. And it's very easy to find. It's just x1 plus x2 over n1 plus n2. So in this case, it would be 195 plus 395. So I think that is 500 out of 1,000, which is just 0.5. So that's something we're going to need. I think that's about it. I can't think of anything else we need. If we do, we'll find it. We'll find it soon enough. Now, guys, the test statistic for this type of test is kind of like what you would think it would be to a certain extent, not totally, but the numerator is going to be just exactly like instead of x bar 1 minus x bar 2, it's going to be p1 minus p2 and minus pi 1 minus pi 2. And since we usually in the alternative hypothesis assume that these are equal, what goes right there is usually 0. Now, you wouldn't expect the standard error to look like this. And this is also, I'll get into this in just a second, but this is also a place where your standard error for the test statistic and your standard error for the confidence interval actually are different. So anyway, this P with the dots above it, the pooled variance, and then we have 1 minus that same number, and then you have something that takes on the same look as the independent samples t-test. All right, so guys, the Z-stat super easy to find. It's going to take a little bit of work, but you know what, man, we could do it, right? So I'll tell you what. Let me get my numbers. All right, so x bar 1 or p1 is 0.39. And next we have 0.61. Of course, this is minus 0. And then we have the square root of the pooled, I know the pooled estimate, what was it, 0.5? So 1 minus 0.5 is just 0.5. That works out kind of nicely. And then we have 1 over 500 plus 1 over 500. So gang, in the numerator, we're going to get negative 0.22. And in the denominator, we're going to get at least I get 0.001. I'll tell you what, let me, no, I didn't take, hold on. It's 0.0316. Now, what I did there, I think it'll be helpful to show. I didn't want to take the chance of putting all that in my calculator, so what I did is I started here and worked out and then took the square root. So I took 1 divided by 500. I knew I had to multiply that by 2 because I have 2 of them. Then I multiplied by 0.5 squared because I had two of those. And then a while ago I said the way 0.01. That's but then I had to take the square root of the answer. And again, if you're not familiar, the answer key is right there, ANS, and so you get 0.03162. So guys, we get negative 0.22 divided by the answer. Gives me a better, so I get negative 6.95, is that right? 957. Well, the p-value is going to be extremely low, so let's just calculate it by hand. So still got some stuff for the dependent samples up. That's fine. I'll tell you what, I'm going to go in and actually so guys, go stat calculator, go normal, and we need the area to the left of negative 6.957. So careful anymore because I transposed those numbers in an earlier video. So remember, this is a p-value that we're calculating, so it's a probability, so it has to be between 0 and 1. This information here tells you we have to move the decimal place 12 places to the left, so essentially we have 0.011 zeros 17. I'm just going to just say p-value very, very, very small. It's got, even when we multiply by 2, it's going to have like 11 zeros, and so extremely small. All right, so we certainly have statistical significance. Let's see the how we calculate the confidence interval. Again, the standard error changes a little bit. Typically, these types of problems, you're okay with using the same standard error for the test statistic as you are the p-value, but this is one place where it works out differently. So anyway, guys, the confidence interval will be P1 minus P1 minus P2. So you use your Z critical, and should have written a little bit smaller here. And let's see, I forget. P1 1 minus P1 over N1 plus P2 over 1 minus P2 over N2, right? Yes. So P1, let me go back to my numbers. So we're going to have 0.39 minus 0.61 plus or minus. Now, guys, keep in mind we're testing at the 0.01 level of significance, so we're going to use a 99% confidence interval here. I know that value is 2.576. If that's something you don't yet have tattooed to your brain and something you don't have memorized, then what I would do, I would go to the between, and I want my between to be 0.99, and I'm going to have my two values that 99% of the Z distribution falls between, so that's the Z critical for the 99%. So you can see it's 2.576. And if you don't have that memorized, that's fine. You're always going to have notes on your test, and when you're doing homework assignment, you can go back and take a look at that stuff. All right, gang. So P1 is 0.39. So 0.61 over 500, and 0.61 times 0.39 over 500. Now, this is going to be quite intense putting it in our calculator. I'm going to run things little by little. So, because I've noticed from some of your all's emails that some of you really do know what you're doing, but you get sometimes caught up in putting it in your calculator. So if I was going to do this, what I would do is I would do 0.35, 0.39 times 0.61 divided by 500. Actually, I wouldn't. I would go parentheses 0.39 times 0.61 divided by 500. And then I would add that to 0.61. We could have really just multiplied by 5, couldn't we? Or multiplied by 2. All right, so I get that. That gives me everything under the square root. So then I would multiply by, or I would take the square root of that, and I would multiply by 2.576. Now, what I got there is I have everything right of the plus or minus. I'll show you what I'm going to do. There is a button on your calculator that says store. And it's right to the left of the 4 and 1. If you've got a calculator like this, you can store it. And I'm going to store it as the variable x. So it's kind of handy because everything to the right, the margin of error, is 0.0796. Now what I'm going to do is I'm going to use 0.39 minus 0.61 minus x, and then I'm going to just change that and put plus x. So I get negative 0.299 to negative 0.141, right? So I can also think of that as a percentage, so negative 29.9% to negative 14.1%. I can also see that as negative 0.299 less than or equal to pi 1 minus pi 2 less than or equal to negative 1.41. So the difference in the percentage of women who use their mobile devices to buy clothing compared to men, it seems like it's about somewhere between 30% and 14% lower for men than for women. And you know, sometimes that direction can get it can get complicated. You know, you get negative and you really forget which one indicates higher or lower. Well, guys, you can always go back to your sample statistic. And when your sample statistic is higher for females, it'd be kind of goofy statistics if you indicated that the percentage of females who use their mobile device to buy clothing was lower. So you can always go back to get an indication of which is higher just looking at your sample statistic. Now, you can't look at this and determine their statistical significance, but you can look at it if there is statistical significance and work back to see which one is higher. So when I look at this, this information right here, the 0.61, because women are higher, I can kind of look at it different. I can say, well, the percentage of women compared to men is about 14.1% to 29.9% more women than men, or 29.9% to 14.1% less males than females. Well, guys, let's go to StatCrunch. I tell you something. I'm trying to make an attempt to keep my videos shorter. I was at a workshop, a conference actually in Puerto Vallarta, which, and I know it was me, but I was at a conference there this weekend, and one of the best speakers. I mean, this guy was so charismatic, and he was so good, and his wife was too. They were both just a really really good looking couple, charismatic, well spoken, and highly successful. But the guy went on too long. He really is. What he could have said that would have been so much more effective at about 15 minutes, he went on for about 45 minutes. Again, he was such a good speaker, and it didn't even work for him. And everybody was kind of losing him after about 30 minutes because he was just, you might say, well, Doug, you're doing the same thing right now. You're rambling. But anyway, I'm going to try to, I actually learned from that. I'm going to try to keep my videos briefer, to the point, more concise and clear, and not get on tangents. Now, guys, I'm going to get on tangents. That's just who I am. But I'm going to try to minimize that. So, guys, let's do it. So stat, I have a z-stat, and I have a 2 sample, and that's not where I want to go either. I want to go to proportion stat, just seeing who's paying attention. Actually, I wasn't. I had a moment. So go to proportion stats, 2 samples, and guys, I have with summary. Now, what would data look like here? Well, for variable 1, I would have no, yes. I would have 500 total for men, and I would have 300 let's see, 195 yeses for using their mobile device, and I would have 305 no's for not using their device. The second column would be females. I would have 500 entries right here. I would have 305 yeses, and I would have 195 no's. So that's what it would look like if I was using raw data. But I'm not, guys. I'm going proportion, 2 sample with summary. So the number of successes in the first is 195. So this is for the female, or for the males. My bad. Number of successes was 305 out of 500. All right, so P1 minus P2, this technically should be pi1 minus pi2, but a lot of textbooks, instead of using pi and p for the population and sample respectively, they use p and p hat. So it's just one of those things you got to tattoo to the brain, the differences. So guys, we compute and we get our counts. Sample difference is negative 0.22, as we knew, and the z statistic was negative 6.96, which we also got. And our p-value, it's so low it doesn't even report it. It just says that it's less than 0.0001. Now, if I'm going to do the confidence interval, Megan, again, thank you for teaching this to me. 0.95. So you can see that the lower limit is 0.28, the upper limit is 0.15. Now that varies a little bit from what we got, and the reason is the reason it varies a little bit is the standard error has been calculated differently. Now that's again, StatCrunch is using the confidence interval standard error, the same as the test statistic. Your textbook presents it differently, so guys, that's confusing. So if you run into a problem with a confidence interval, where you get it wrong, you might have to calculate the standard error by hand. So sorry, I know that's not what you want to hear, but it's just the way, and I knew it was coming, and there wasn't anything I could do about it. It was just it was getting ready to happen. Now, one thing which is much more consistent than that is reporting confidence reporting test reporting p-values. So here's typically when you report p-values. Here's the method that we use. If a p-value is greater than or equal to 0.05, report it. If your p-value is between 0.01 but less than 0.05, you report that as p less than 0.05. If your p-value is between 0.001, that should be just less than, strictly less than 0.01, so ignore. Then you report this as p less than 0.01. And if your p-value is less than 0.001, then you report that as p less than 0.001. Those are the 4 ways to report p-values. So if you get a p-value 0.32, that's bigger than 0.05, you would report it. If you get a p-value 0.018, that's less than 0.05, but it's higher than 0.01, so you would report it at p less than 0.05. Anything between 0.01 and 0.001, but greater than or equal to 0.001, you report it this way. So just a little bit of extra information on how you report p-values.